2 and 3 questions we have done in the previous class. Okay. So today we'll be going to discuss the very important questions that are generally being asked and the question related to that being asked in the examinations. Okay. So
Okay.
NCRT is very important and we need to do that one. Okay. So
Okay.
quadrilaterals, just doing circles. So here we have another question. Today we shall be discussing this question. Okay. Is my screen is visible to you now?
Yes, sir.
Yes, sir.
So here we have this one, that if two chords, what was the questions that we have done in the previous class? We have done a theorem. Okay. And what was that theorem? That theorem was that when there are the two chords, then the two chords are equal. Okay. If the two chords are equal, then their perpendicular distance from the center must be equal. Okay. This theorem we have done. Have you seen that one?
Yes.
Okay. So if I talk to you that, okay. So if I talk to you that we have done this type of theorems, and in this theorem we have done that AB is equals to CD. Okay. And this is E and this is F. So in the previous class we have discussed that this is the theorem that if the two chords are equal, then the perpendicular distance between their centers are equal. Okay. Got it?
Yes, sir.
Means this is the theorem that if AB is equals to CD, then then the perpendicular OE and perpendicular OF on AB and CD will be equal. This is a theorem and that we have studied in the previous class. Okay. Got it?
Okay, sir. Yeah.
Okay. So now in this question, this is being given to you that if two equal chords of a circle intersect within the circle. Okay. This is an important question, that if two chords of a circle intersect within the circle, then prove that the line joining the intersection, the point of intersection of the circle make equal angle with the chords. So what does this means actually? So let's discuss this one again. Okay. So what is it saying here? That if suppose we have two chords, okay? If suppose we have two chords here in this one, okay? And let's suppose if I talk to you here is, okay? And this is the center, okay? This is the center of the chord. Okay, you understood? Let's suppose.
Yes, sir.
And this is the chord. Okay, this is a circle. And in this circle, if I'm saying that these are the two chords, then this is, and they are intersecting each other. They are intersecting each other. This is AB and this is CD. Got it? Got it? So
Yes, sir.
Yes, sir.
what here it is saying? Okay. Yes, what it is saying here is that if there are two chords, okay, this is AB and CD, AB and CD are the two chords and they are intersecting at point O. So you need to prove that. What do you need to prove that? You need to prove that the intersection where they are intersecting, their intersection part, corresponding part of intersections make equal angle with the chords. Okay. Means they are making equal angle with the chords. Means this angle is equals to this angle. You need to prove. Okay. Prove that the line joining the point of intersection from the center, from the center, the line joining the point of intersection where they are intersecting make equal angle with the chord. This is angle 1, this is angle 2. You need to prove that these are equal. Got it? You understood? You understood? Will you be able to prove this one? How will you prove? Tell me first. How will you be able to prove this one that they are making, if you consider that this is the center, consider this O point is the center, then how will you be able to prove this one? And now this is perpendicular, this is perpendicular here. Here we have A, B, and this is point E where they are intersecting. Tell me how will you be able to prove this one fast? How will you be able to prove?
Because the chords are equal.
The chords are equal because that's why.
Equal.
No.
Yeah.
Okay. Let's you know that this is a equal chord I'm having on this circle. Okay. And this is actually intersecting at this point, and now this is the center. Okay, so you know that if these two chords are equal, this is AB and this is CD, and this, if these two chords are equal, then their perpendicular distance must be equal. Their perpendicular distance must be equal.
Yeah.
Got it? So this is AB, this is CD, and this is EF. Okay, or you can take it EF. I'm just not making this one, or you can take this one E, and this is take this F, and this is G, and this is O. So the perpendicular drawn on equal chords are equal. The perpendicular drawn on equal chords are equal. So you will take this triangle, okay, and this triangle. In this triangle, this will be equal to this because the two chords are equal. So the perpendicular drawn on the equal chords will be equal. Okay, the second reason will be this. Okay, the second reason will be, tell me fast, that this is a common chord and this is the 90-degree. So this is the in front of 90-degree. So this will be hypotenuse. This is side. So by RHS, this triangle EFOE will be congruent to triangle OGE. Got it? Got it? You
Yes,
understood? So by, you didn't got this one. So let me explain you. I'm just making these two
I
triangles
was
here.
getting understand you.
Okay. This, I'm just making these two triangles. This is F, this is O, and this is G, and this is E here. Okay. We need to prove this angle is equals to this angle. Got it? How will you be able to prove this one? How will you be able to prove this one? Okay. Now you know that OF is equals to OG. OF is equals to OG. Why? Why? Because these two chords are equal. And when we have a theorem that when these are two chords, okay, they are the two chords and equal chords, and the perpendicular distance from their center are equal. And the perpendicular distance from their centers are
equal.
equal. Got it? So this will be equals
Yeah.
to, okay, this side will be equals to this side. Okay, OF will be equals to OG because these two chords are AB and CD are equal chords and they are perpendicular. These are OF and OG are perpendicular. So the perpendicular drawn on equal chord from the centers are equal. Got it? Got it?
Yes. Yeah.
Okay, next is, you will take this side, you will take this side. Okay, you will take this side as common in both. Okay, and since it's
Yeah.
90-degree, it is 90-degree. Okay, and this is also 90-degree. Got it? So
Yes.
by RHS, right angle, R for right angle, H for hypotenuse, the in front side of this one, okay? H and S is one side we have taken. So by RHS, this FOE triangle FOE will be congruent to triangle GOE. So by CPCT, this angle will be equal to this angle. So do this one, please. Do this
Okay.
one, please. Done? So do you understood this one?
Yes, sir.
Okay. So let's start doing this one. Given to you that is equals to CD are the two chords. Okay. To prove if this is E here, this is F, and this is G, and this is O. To prove angle FEO, angle FEO is equals to angle GEO. GEO. We need to prove this one, okay? Now you will take in triangle FOE and triangle GOE. Okay. Now you'll write here that angle you will write first of all you can draw the constructions here. Okay, you have to draw one thing here, that construction you have to do. Construction draw OF and OG perpendicular to AB. OF first, this is AB first, and CD respectively. Okay, then prove. You will take in triangle FOE and triangle GOE. You will write here that OF is equals to OG. Why? Perpendicular drawn. OF is equals to OG. Reason is perpendicular drawn on equal chords from center are equal. Okay, this is the first one. Now second, what you will write, what are you going to write? That is OE is equals to OE, common, and angle this is 90 degree. By construction we have done this one as 90 degree. So we'll take angle OFE is equals to angle EGO. Okay, EGO, sorry, no, EGO is equals to 90 degree. OFE is equals to EGO is equals to 90 degree. By construction we have drawn this one. Okay, so by RHS triangle FOE congruent to triangle GOE, therefore by CPCT angle FEO will be equals to angle GEO. Okay, yes, we have proved this one. Understood this question?
Yes, sir.
Okay. So copy this one fast. Here, do a correction here. It is OF and OG. OG here. Okay. Done this one. Should I move toward the next question? Should I move?
Yes, sir. Yes.
Okay. So here in the next question, we are just going to have we have the next question. Uh, this similar question is question number 3, but there is a difference, little bit difference in this one. Okay, so let's do that one also. Mhm.
Okay.
Just a minute. There is a question on your screen. Just a minute. So here is a question on your screen. Please note it down. Next question. So how will you do this one? This is an important question. So how will you do this one? This is similar to original one, previous one. Okay. So read this question. The two chords, again, the two equal chords of the circles intersect within the circle. Prove that the line joining the intersection. This is the make. This is the same question that we have copied. Okay, just a minute. This is the same question. Just it is the same question. Let me take the different one. Okay, just a minute. Do this question, please, on your screen. Note this question, please. Note this one fast. Have you noted?
Yes, sir.
Rima, you understood the previous question?
Yes, sir.
So what's saying in this question? That if two chords of a circle intersect within the circle. Okay, they are the two chords of a circle intersect within the circle. Okay, then prove that the segment of one chords is equal means is one of the students is having their mic open. Please mute your mic. A, B, and here we have C, D. Okay, and this one is they are again intersecting. Okay, now you have to prove that their corresponding parts are equal. Prove that this segment of one chord is equal to the corresponding segment of the another chord. Okay, means what is saying that if AB is equals to CD and it is intersecting at point E, then you need to prove that F, and here is EF again. I'm just drawing here. Sorry, FG because E is here. You need to prove that AE AE is equals to CE and B EB is equals to ED means indirectly we can say that you need to prove that this side is equals to this side and this is equals to this. You need to prove this one. How will you be able to prove this one? Tell me first. Is there anyone who is going to help me to answer this question? Rima, would you like to answer me?
Yes,
Alvina,
sir.
you?
It's the same way because the chords are equal, then the center also is the same.
Yes, you, Alvina?
Sir, we can construct a line AC and
Okay.
then construct another line bisecting the triangle.
Yes, first of all, we will draw this one like the previous construction we have done. Okay, we'll join this one. So let's start. Okay, just concentrate here. This is an important part. So again, this is to prove, and what is given to you here is actually it is being given to you that AB is equals to CD. Okay, AB is equals to CD means the two chords are equal given. Okay, the construction again, you have to do a construction here. And what is the construction here? Construction is draw OF perpendicular to AB and OG perpendicular to CD. Okay, this is the construction. Now what you are going to do here is, let me first explain you that how you are going to prove this one. Actually, you know that this portion, because the two chords are equal, by the theorem we know that if we are just drawing a perpendicular from a perpendicular that is drawn from the center on a chord bisect the chord. We have this rule. Okay, we have this rule that if we are drawing a perpendicular, then it is going to bisect the chord. If you are drawing a perpendicular from the center, then it is going to bisect this chord. Okay, so here if we have this triangle, like if I'm having this one, okay, this portion, and if this is being given to you that this is equals to this whole portion. Okay, and this portion here is equals to this portion because this is the perpendicular. It is going to bisect this chord and this is going to bisect this chord. Okay, this is being given to you. But what actually you are going to do here is that you need not to prove the whole. AF is not equals to FB. You need to prove AE. AE. Okay. AE is equals to CE. So what actually you are going to prove here is that, first of all, you need to prove that this portion is equals to this portion. This is very simple. Okay. And then you need to prove that this portion is equals to this portion, means FE is equals to GE. And when you add green plus violet and green plus violet, you will get AE plus CE. Okay. So how can you prove? First of all, you need to prove that AF is equals to GE. So now, how can you prove this one? This is very simple, that you will take proof. Okay, you will take that CD is equals to AB is equals to CD. AB is equals to CD. Why? The reason behind this one is that it is given to you. Okay, so half of AB will also be equals to half of CD. Okay, so half of AB you can take AF, and half of CD you can take CG. CG. Why? Reason? Because perpendicular drawn on equal chords, drawn on equal chords, or perpendicular drawn on chords chord from center bisect the chord, bisect the chord. Okay, this is the rule, this is the theorem, that if you are drawing a perpendicular on a chord, then it is going to bisect the chord. So AF is equals to FB. So we are just taking half of CD as AF and half of CD as GC and half of AB as AF. So green portion we have proved equal. This green portion AF is equals to GC we have proved. This is the equation 1. Okay, you understood? Understood? Understood this one?
That's not clear.
This is very simple, that you have been given that AB is equals to CD. It is being given that this whole chord is equals to CD. This is given to you. So half of AB will be equals to half of CD. If you divide it by 2, both sides, it is equal. If you are saying that 10 is equals to 10, so if you divide it by 2, you will divide by 2, you will get 5 is equals to 5. The same half of AB will be equals to half of CD. Now half of AB can be considered as AF, and half of CD will be considered as CG, this portion. So this green portion, AF and CG, you have proved equal. Now you need to prove violet. Yani you have to prove FE and GE equal. FE and GE equal. Okay, now proof. Now for this proving, you have to prove that these two triangles are congruent. FOE and GOE. So you will take these two triangles to prove this two congruent. And how will you be able to prove this one? Let me take this one. Okay. So this is very simple. You can prove it. You will take this two triangles again. Okay. And I'm just drawing this one for you again. This is the center here. Okay. This is AB. And this one is CD. Okay. And this one is 90. And this one is O. Here we have E here, we have F here, we have G here. So you need to prove that FE is equals to GE. You need to prove these two sides as equal. Okay. So how will you prove? So you will take in triangle. Now in triangle FEO. FEO and triangle. If you have taken FEO, then the other triangle will be GEO. Okay. Now you have taken that perpendicular drawn on the equal sides. You have drawn this perpendicular and these are the two equal chords. So like the previous one, you will say that OF will be equals to OG. Why OF will be equals to OG? Why OF will be equals to OG? Why OF will be equals to OG? The reason is that these two chords are equal, and when the two chords are equal, then the perpendicular drawn from the center on these chords are equal. This is the theorem. Reason: perpendicular drawn on equal chords are equal. This is the reason. Okay. And now you will see that OE is equals to OE, common. This is common. Okay. This is common. And the next one is, angle 90 degree. Okay, 90 degree. You can take this angle. Okay, angle OFE. You can take angle OFE. Angle OFE is equals to angle OGE. OGE is equals to 90 degree. Okay, you have proved this one. This is by construction. You have made this one perpendicular. So by construction. Now what you are going to do here is that, so again by RHS, these two triangles congruent. Triangle FOFEO will be congruent to triangle GEO. Okay, GEO. Got it? This will be congruent. You understood now? Tell me fast. Up to here, everybody got this one? Tell me fast.
Yes, sir.
Okay, sure. Note it down till here. Note it down fast. Let us start. Okay. Now, what we are going to do? We have proved this one. Now, what we have? So why we are just proving this one? Okay. So if I talk about this one, that, okay, you understood this one. So if I'm talking about this one, that these two triangles you have proved congruent, and if you have proved this congruent, so what is the purpose of proving these two triangles, this triangle and this triangle congruent? Why we are proving this one? The reason is that by CPCT we can prove that FE will be equals to GE. So by CPCT you can write here, if the two triangles are congruent, so by CPCT you can write, what you can write here? You can write FE is equals to GE. Okay, understood?
Yes, sir.
Understood? Okay. Now what we are going to discuss here is that, okay, now we have proved this one. In the previous one, if you see this one, that green we have already proved that this AF is equals to GE. We have proved. And the violet lines we have also proved FE is equals to GE. Okay. Now if you add green plus violet and here green plus violet, so you will get AE will be equals to CE. Okay, so this is the first equation and this is the second equation. So adding first and second, adding first and second, what you are going to get? You will get AF plus FE will be equals to CG plus GE. CG plus GE. And what is AF plus FE will give you? It will gives you AE. And second, what GE plus CG plus GE gives you? This will give you CE. So we have proved CE. So this is our third equation, and this we have to prove. So this we have proved. Now what we need to prove? We need to prove that CD is equals to ED is equals to EB. We need to prove this last portion. What we need to prove here? We need to prove that this is equals to this. Now you know that this whole, if I compare this one, that this whole red color line, which is the chord AB, and this whole another red color line, that is CD, they both are equal. They both are equal. Okay. And you have also proved that if I'm just taking this with color, that this green color line CE, that is CE, and this another green color line, okay, another green color line, that is AE. Okay, AE. You have proved this one equal. So what if you have subtracted the red line and green line? Red means green line from the red line. You will get the blue line part only. So this is, suppose this whole as a red color CD, and you subtract the green from it. Just imagine that you are subtracting the green from it. You will get only this EC part. And similarly, this whole red color line, this is AB, is subtracted, means from this one, green color line is subtracted. Means this you are cutting this one. So you will get only this portion. Okay? You will get only this portion. You understood? Understood? Let me explain you one more time that what you are going to do here is, what you are going to do, you are just going to subtract this whole red color portion. If you subtract this portion, that you have also proved that this whole red color portion, if you delete this portion, then only the blue color portion means EC is going to be there. So you just look at this and concentrate, try to concentrate here. So you will write here that we know that AB, okay, that AB,
Sir,
yes, AB is equals to, just concentrate here, AB is equals to CD. It is being given to you. AB is equals to CD is given to you. This is the fourth equation. Okay, it is given. And if you subtract third from fourth, so what you will get? If you subtract AB minus AE, and similarly CD minus EC. So AB, this whole, if you are subtracting this portion from it, you will get only this portion. Okay, so you will get EB. Okay, and similarly, if this whole CD, and if you are subtracting EC means this portion. Okay, you are subtracting, then you will get only this portion. Okay, this will be ED. And this we have to prove. This is our fifth equation. Okay, we have proved, hence proved. Okay, you understood? Everybody understood? Tell me, Alvina, you understood this one? Tell me, you understood this one or not? This is an important question. Rima, you understood? Rima, are you
yes,
there?
yeah, yeah,
Yeah, please copy this one.
okay. That's
Yes, you, Alvina, copied this one, this question.
Yes, sir.
Okay, so let's move and have a next question here. Okay, let's have a next question. Just a minute, just give me a minute. Let's study the theorem, next theorems. We are just going to study 9.7. Okay, and let's study these theorems. These are important theorems. So first of all, what we are just going to study here is mm, here is theorem. Here is theorems 9.7 on your screen. What does it say? The angle subtended by an arc, okay, by an arc at the center is double the angle subtended by its remaining part of the circle. So what is saying here that if you are having an angle, okay, and let's suppose the angle subtended by an arc at the center. So just a minute here. What we are just going to do here is just need to draw the circles. Okay, here we have a circle in front of your screen, and what is saying here is that the angle subtended. Okay, if you are just having a chord, okay, and you are just making an angle at the center, then it is double the angle formed by the same another. So if I'm having this chord like this, okay, and this is an arc. So if this is making angle x, okay, so the angle subtended by an arc at the center is double, means it is double the angle subtended by it and any point of the remaining part of the circle. Means that if it is making an angle, okay, so you can write it this one like this way, that if it is 2x angle, then it will be the x angle. Okay, if it is 60 degree, then it would be 30 degree. If it is 100 degree, then it will be 50 degree. Okay, you understood this one? You understood this one? That what is I, or in other words, what you can write here is that the angle subtended by the chord at the center is half the angle subtended by the same chord at the circumference. Okay, what it's saying here, the angle subtended by a chord at the center is double the angle subtended by the chord by the same chord by the same chord at the circumference. Okay, so what is saying here that if you are having any chord, let's suppose if this is a chord here, okay, and if it is subtending any angle here, okay, so this chord, if it is subtending angle at the center is actually 2x, then this angle will be equals to x. Okay, this same chord, if this AB is a chord and it is subtending an angle at the center, then the same chord will be subtending this angle at the half the angle of this, which is means which is it is making at the center, then that will be the half which is making at the circumference. Okay, you understood this one? Understood this one? The next thing that you need to understood here is that if I just keep on bringing this chord, okay, let's suppose I'm just making this chord, another chord with green color, okay. So as you know, if I just keep on coming at the center, the angle which is it making at the center will keep on increasing. Okay, now you know that you can see that this angle is actually bigger than the previous one, which AB chord is making. Let's suppose this is the CD chord, okay, and this CD chord is making whatever the angle CD chord is making, that will be greater than the chord that is making AB, or that is the angle that is made by AB chord. Okay, so this angle is bigger than this angle. Okay, and if I keep on increasing and if I just move towards the center, if I just keep on moving towards the center, the maximum possible angle that a chord can subtend at a center is 180 degree. So here, let's suppose this is the another angle which it is making, but it is less than 180 degree. But what if we are just having another chord and this is passing just exactly towards the center? Oh, sorry, by the center. So this chord, actually the violet chord is actually making exactly 180 degree at the center. Okay, 180 degree, and actually EH is diameter of the circle. Okay, so what diameter, how much angular diameter make at the center? A diameter is going to make 180 degree angle at the center. Then it will be going to make 90 degree at this circumference, because half of 180 is 90 degree. 90 degrees. So it is understandable that whenever a diameter is making an angle with the circumference, it will be always 90 degree. So note it down. By this theorem, by this theorem, a diameter always make 90 degree at the 90 degree angle 90 degree angle at the circumference circumference. What I want to say here is that if I just keep on moving, this angle will keep on increasing, and the maximum possible this angle can be is 180 degree. Okay, so half of 180 is 90 degree. So a circumference, the possible angle that a chord can make, the maximum angle a chord can make at the circumference is 90 degree. Is 90 degree. Okay, the maximum angle a chord can make at the circumference is 90 degree. Let me explain you one more time this one. That what I'm saying here is that let's suppose if we are just having any chord, okay. And if it is the diameter of the circle, then it will be always making 90 degree at the circumference. This is 90 degree. Here, if it is making like this will be also 90 degree. If it is making like this, then it will be also 90 degree. This all angle will be 90 degree. You understood this one? Understood this one? Tell me fast.
Yes, sir.
Yes, sir.
Okay. And if this is not a diameter, let's suppose if it is not a diameter, let's suppose if I'm talking that this is a red chord, I'm just making this one is, so actually this is making 180 degree here. Okay, that's why it is making 90 degree. Half of this one is 90 degree. If this chord is making 120 degree angle, let's suppose it is making let's suppose not 120, let it is be 100 degree. Okay, then whatever the value of this one at the center, at the circumference, what will be the value of this angle at the circumference? It will be 80 degree. How much it is? It will be, sorry, not 80, this will be 50 degree. 50 degree, half of this one. If this is 100, then this will be 50 degree. Okay, you understood? Understood? This is an important theorem. Got it? The next theorem
Yes.
is that whenever a chord always make equal angle at the circumference. A chord always make equal angle at the circumference. Okay, what does it means? That suppose so what does it means? Let me explain you. Let's suppose this is a chord. Okay, and if this chord is making any angle at the circumference. Okay, so this, if let this is angle x, then this angle will be also x. This angle will also be x. Okay, this angle will be also x. Okay, understood this one? This angle will be also x. So these all angle will be x. Why? Because let's suppose this is the center. This is the center. If the same chord is making 2x angle at the center, 2x angle at the center, 2x angle at the center, then the same chord here at the circumference will be making x. The same chord will be making angle x. So this all will be this way. That's why they will be equal. Okay. So the angle formed by a chord at the center is equal. You understood this one? Understood? Tell me fast.
Yeah.
Yes, sir.
Okay. Okay. Next, what we are just going to study here, that one more theorem, that what is cyclic quadrilateral? What is the property of cyclic quadrilateral? Just you understood this one, then we shall be starting practicing question. Okay, so if I'm having this a circle here, okay, like this, and if there is a quadrilateral which is formed inside a circle, okay, if there is a quadrilateral which is forming inside a circle, then this quadrilateral will always, okay, if this is a quadrilateral, okay, this is A, this is B, this is C, and this is D. What is cyclic quadrilateral? Cyclic, what is cyclic quadrilateral? Cyclic quadrilateral is a quadrilateral actually whose all the vertex lies on the circumference of the circle. This is a cyclic quadrilateral, this because it's all vertex are lying on the circumference of the circle. If I talk about this one, if I take this circle, okay, and if I take like this, if I'm just making drawing like this, so this is not a cyclic quadrilateral because this vertex is not lying on the circumference. This is lying inside the circumference. And similarly, if I'm having another like this one is also not considered to be a cyclic quadrilateral because means all the vertex, the quadrilateral whose all vertex lies in on the circumference of the circle. A quadrilateral lateral whose all vertex corner lies on the circumference of the circle. Whose all vertex lies on the circumference of the circles. Okay. So this is called cyclic quadrilateral. And what is the property of cyclic quadrilateral? Tell me, what is the property of cyclic quadrilateral? What is the property of cyclic quadrilateral? The property of cyclic quadrilateral is what is the property of cyclic quadrilateral? That the sum of the opposite angles are actually, the sum of opposite angle is 180 degree. In parallelogram, opposite angles are equal, but in cyclic quadrilateral, the opposite angles sum is 180 degree. Okay. So the important thing is that you need to remember here that in a cyclic quadrilateral, the sum of opposite angles, the sum of opposite angle of cyclic quadrilateral is 180 degree. Okay. So this property is very important. And in the next class, we shall be discussing these properties. So practice these questions that we have done today. Okay. And in the next class, we're going to discuss that what the question that are based on the theorem that we have studied, that if a chord is making equal angle at the center, okay, the chords are making double angle at the center, then the angle formed by them at the circumference, the same chord forms equal angle at the circumference, okay, the opposite angle of quadrilaters are having some 180 degree, okay, like here.
Okay.
You can write here that angle A plus angle C will be equals to 180 degree, and angle D plus angle B will be equals to 180 degree. So we were going to prove this one. So that's all for today. We'll meet you in the next one. I hope you enjoy the class.